In this video I'm going to show you the two transceiver remote control modules in action. So now they are actually communicating over the air, and each of them is connected to a serial terminal. So the one that would be on the aircraft is connected to this black body terminal, and the one that's in the handheld transceiver is connected to the Arduino terminal. So when I enable the transceiver to transmit data frames, then here in the receiving window we see characters appearing, because the data is actually hexadecimal code, so there are just bytes at the output of a serial connector. So to visualize this better, I have implemented a debug mode that would transform the output into human readable hexadecimal strings. So here we see the control frames appearing. So these are frames that start by EE hexadecimal. The second byte is the overall length, and the third byte, the 16, it means that it's a 16-channel control frame. And on the window of the transceiver we see two types of incoming data. So there is one frame that is generated locally, and this is giving the link statistics. So it has the format of a telemetry frame. It starts by C8 hexadecimal, then the next byte 6 is the overall length, 14 it means that is a link start frame, and then we have here the signal strengths on the transceiver side, the signal strengths on the receiver side. Here we have the link quality, it's the percentage of packages that are validly received. This one is the signal to noise ratio, and the last byte is the cyclic redundancy check. So this one is a real incoming frame that is transmitted by the module in the aircraft. So it's also C8, meaning it's a telemetry downlink frame. 01 is the overall length, and then for the type I just put 0. So this is actually no type at all, but it's just a empty an empty telemetry frame. Here on the left column we have the sequence number, and we see that that is locally generated frame. It's generated every 10th sequence, and the receiver that's on the aircraft is also replying to one frame out of 10. But there's an offset, so it's every 10th time, but an offset +1 is applied, so that this packet that's actually transmitted over the air is not colliding with the locally generated link start frame. So a special feature of the firmware is that it's possible to modify this offset, and thereby it is possible to assign a specific dedicated slot number to each receiver. So this would enable us in a one transmitter n receiver configuration to assign a dedicated time slot to each receiver. So now let's start it again. And now we realize that that the telemetry downlink frame is offset by 5 sequences compared to the locally generated frame. So this allows us to have as many receivers as the telemetry ratio. So it means if I have a telemetry ratio of 32, then I can have one transmitter and 32 receiver, and every transceiver is broadcasting its data in its dedicated time slot without causing any collisions. Okay, so that's for today. Next video it will be about the implementation of channel hopping. So I will show you on a software-defined radio how looks the spectrum of the signal with and without channel hopping. Thanks for watching. See you next time. Bye bye.